Biogas is the name given to the mixture of gases generated by the biodegradation of organic substances under anaerobic conditions, of which the main component is methane CH4. Biogas technology can bring many benefits to farmers, among which eliminating raw and untreated animal manure and preventing infectious diseases, long-term improvement in the financial situation of households by reducing fuel and chemical fertilizer expenses, improvement of soil fertility and reduction of soil degradation by the use of the biodigesters digested effluent as organic fertilizer, reduction of the pollution caused by chemical fertilizers, as these are totally or partly replaced by more environmentally friendly organic fertilizers, reduces the workload of women for fuel gathering and cleaning of pots and pans, reduction in CO2 emissions, and reduce deforestation pressure by substituting fossil fuel with biogas. About biogas technology in Vietnam. Family-size affordable biogas technology was introduced in Vietnam in the early 90s. Since then, various models have been implemented, evaluated, and modified. No model is perfect at present. However, for vigorous speed-up of households' participation in biogas technology, it's necessary to have a suitable biogas model, which is in accordance with socio-economic development conditions of rural areas, and is most important to be suitable to traditional habits of rural farmers. VACVINA biogas model is one that is suitable for the condition of Vietnamese rural areas. Instruction on how to construct the improved VACVINA biogas plant. Required construction materials. The construction material required to build a standard 7 cubic meter VACVINA biogas digester. Item: A standard solid brick, 1400 pieces, cement, 600 kilograms, coarse yellow sand, 1 cubic meter, gravel, 1 cubic meter, stone on rubber bricks, 0.5 cubic meters, iron bars, construction steel, 5/8 millimeters, 30 kilogram. Excavating the pit. After selecting and covering the construction site, excavation is started. The dimensions of the pit must be larger than those of the digester so as to facilitate the execution of the work. The dimensions of the digester can be tailored to specific configurations. However, to minimize investment and maximize efficiency and ease of operation, it is suggested to keep the depth to maximum 3 meters, the width to 1.5 to 2 meters, and to adjust the length to obtain the total volume required. Important note: when the excavation is carried out in an area of high underground water level, it's necessary to dig a ditch around the construction pit. Throughout construction of the digester base, water accumulating in the ditch can be pumped out to keep the site dry. After completing the excavation of the pit, the following steps are required to build the base. To prepare a first 15 cm bottom layer of tightly compacted broken bricks or crushed stones. Dimension of 4 by 6 cm. Pour a 5 cm concrete foundation using 1 part cement, 2 parts yellow sand, and 3 parts crushed stone. Important notes: whether soil is of weak bearing capacity, metal rods, rebars, 5-10 mm should be used for the concrete layer. Accumulated water must be pumped away regularly. Use inexpensive plastic sheeting to protect the base from excess water. Add metal rods, rebars, in the concrete slab when the soil has weak bearing capacity. Allow at least 24 hours for the concrete to cure. Building the walls of the digester. The walls are constructed after the base has been left to cure for at least 24 hours. The thickness of the walls is the standard 10 cm. The bricks used must be solid grade A. The mortar is made of 1 part cement to 4 parts cold sand. Important note: during the construction of the walls, remember to leave the technical openings for the installation of inlet-outlet pipes. The hole for the inlet pipe is around 30 cm diameter and starts from the top of the wall. It can be located on any wall. The hole for the outlet pipe is rectangular 30 cm high by 25 cm wide and is located 40 cm below the upper edge of the wall. Plastering the walls. The plaster applied on the inner side of the digester plays a very important role in ensuring permanent gas and water tightness. Plastering mortar is made of clean fine yellow sand mixed thoroughly with cement, 1 part cement to 3 parts sand. Special care must be taken to ensure even thickness of the plastering layer. The surface must be smooth and regular and all edges must be rounded. The following steps must be followed. Clean and scrub the entire surface to be plastered. Plaster a 1 cm thick layer. Wait for this layer to dry slightly and use the hand trowel to press the entire surface evenly. Wait 1 to 2 hours for the layer to dry, then plaster a second layer in the same manner. Polish this final layer with pure cement solution. Here's an important note. The top 5 cm of each wall must not be plastered. This wall surface will be plastered once the digester cover is installed. The final plastering must be applied properly at the connection area between the wall and the cover with rounded edges to ensure proper gas. Casting the ferro-concrete cover. After plastering and polishing the walls, it's time to construct the digester cover. Because the flat top cover is used to support the pigsty, animal stable, inn or latrine, it must be at least 10 cm thick, flat-shaped and casted in place. Do not use a precast concrete slab. The procedure is the same as that used to build a house foundation and comprises the following steps. Prepare a solid formwork for casting the cover. Use scaffoldings to support the wooden framework. Define the location of the manhole to provide easy access to the digestion chamber while not interrupting animal production activities. Prepare a wooden mold shape as a truncated V-shaped rectangular column with upper dimensions of 50 by 50 cm, lower dimensions of 45 by 45 cm, and a height of 10 cm. The manhole performs the following functions. Provides access to the digester inner chamber to remove the formwork after the concrete has settled and to install the accessories, inlet, outlet pipes, gas pipe. Provides access to the digester to remove accumulated waste and grit, normally after 7 to 10 years of use. Prepare a 15 by 15 cm mesh of 5/8 steel rods. These are prepared with hooks at both ends of the rods. Position the shorter steel rods under the longer ones for better solidity. If the width of the cover exceeds 2.5 meters, a construction engineer must be consulted to design the proper reinforced mesh configuration. Cast the concrete cover with 200 mark concrete. The basic 1 cement, 2 sand, 3 gravel mixture is used for casting the concrete cover with 200 mark concrete. To ensure even thickness of the cover, several 10 cm wooden pegs are used. Once the thickness of the concrete layer is evenly compacted, remove the pegs. The main gas pipe must be fitted during casting of the cover. Made up of iron 21 mm in diameter, it is fitted right beside the wall of the animal stable so as not to disturb the animal production activities in the future. Compact and sprinkle the concrete is necessary for compacting concrete. Manhole. After 2 to 3 hours, once the surface of the concrete has taken shape, the wooden mold for the manhole cover is removed. Smooth and press thoroughly the edges of the opening. A first manhole cover is then casted in place. Coat the surface and lateral side of the manhole opening with cement layer, lay the steel rod mesh and cast the concrete with thickness of 5 cm. The steel mesh uses masonry 8 mm rods spaced at 10 cm intervals with end hooks. To provide a convenient way to remove the cover, 2 carrying handles made up of 10 mm rods are inserted. The stove platform is made of 6 to 8 cm thickness platform of concrete reinforced by a steel mesh of 20 by 20 cm 5/8 rods with end hooks. The breadth and length of platforms are 60 centimeters and 120 centimeters respectively. For maximum convenience, it's recommended to install the platform 75 centimeters above the kitchen floor. Notes: while constructing the stove platform, two holes 25 centimeters in diameter and 50 centimeters apart must be made. The holes are placed 10 centimeters from the edge of the platform. This will be used to install the gas pipes coming from beneath the platform. Inlet, outlet, and equipment. After constructing the digester cover, manhole cap, and stove platform, the entire concrete work must be protected and maintained in proper conditions to ensure drying and curing. The formwork is removed after 7 days and the inlet and outlet pipes are then installed. Installing the inlet. As defined before, the inlet of VACVINA biogas plant is a simple, inexpensive. Formwork is removed after 7 days and the inlet and outlet pipes are then installed. Installing the inlet. As defined before, the inlet of VACVINA biogas plant is a simple, inexpensive, off-the-shelf siphon pipe, also called rabbit joint or U-bend, made of glazed terracotta or PVC if glazed terracotta siphon pipes are not available locally. Handmade siphons can be assembled with pieces of PVC materials. The system normally comprises 2 or 3 siphon inlets. The number of inlets is based on the size of the digester and commonly 2 to 3 per digester. It can also be fed by the lavatory pan, so the latrine to be connected to the system is a priority. These inlets play an important role in preventing the formation of a hardened scum layer by allowing the new material to drop on top of the liquid surface, thus wetting and breaking the top layer. As new material is fed daily, the surface is continually stirred and broken. In addition, the siphons also act as pressure safety valves. With 15 centimeters of water column pressure, they effectively ensure gas tightness of the main chamber, but should the internal pressure increase over this limit, excess gas will bubble out. The right position of the siphon is always and carefully required at installation. For this, once positioned in place, the siphon pipe is slightly sloped at a 30-degree angle. The highest point of the pipe should be 5 centimeters higher than the top of the opening. In this position, when water is poured to fill the siphon, it will start running at the other end as the lever reaches the lip of the opening. Fix the pipe firmly in this position and seal the joint with mortar. The mixing tank is then constructed around the inlet. Its function is to collect and mix the fresh material before fitting it to the digester. It can be covered by a net to prevent larger debris and stones from entering the digester. Installing the outlet. The outlet system at VACVINA biodigester consists of an outlet pipe and a slurry holding pit. The outlet pipe allows the digester slurry to flow from the digester to the slurry pit. Its length and position are important as they determine the level of slurry in the digester. The PVC pipe is 110 to 150 millimeters in diameter, with a length equal to 1/3 of the slurry height, 80 to 100 centimeters. It must be positioned at an angle, making sure it extends under the surface of the slurry the equivalent of 1/3 of the height of the slurry. For example, if the slurry in the main chamber is 1.50 meter deep, the end of the pipe must extend 50 centimeters below the surface. Installing the safety valve. The safety valve is important to ensure that gas pressure in the system does not exceed 15 centimeters of water column. It consists of a 1 to 1.5 liter plastic bottle, a T-joint, and 21 millimeter plastic tubing. To install the safety valve, make a hole 1.5 to 2 centimeters in diameter at the neck of the bottle. Insert a short length of pipe into the bottle and connect the other end to the T-joint. Insert the T-joint as part of the main pipeline. Pour enough water into the bottle to cover the end of the pipe by 15 centimeters. Mark the water level on the bottle as a guide to add water when necessary. If the pressure in the system reaches more than 15 centimeters of water column, gas will automatically bubble out of the pipe and of the water bottle. Important note: check the water level regularly. If the level falls below the 15 centimeter mark, water must be added immediately to prevent gas leakage and reduction in gas pressure. Place the safety valve in a well-ventilated area and where it is easy to see the water level, and add water in the bottle when required. Gas is stored in the gas reservoir until used for cooking. The plastic reservoirs are suspended under the stable roof or in an area where they are not subject to be punctured or affected by sunlight. The gas reservoir is made of two layers of 20 to 24 micron polyethylene tubing, 100 centimeters in diameter and 2.5 meters in length. One end of bag is tightly tied while the other is connected to the pipeline with 21 millimeters plastic tubing. The storage capacity of the reservoir is 1.8 cubic meters and is enough for the 4 to 5 hours of daily cooking required by a typical family of 5 to 6 persons. How to assemble and install the gas reservoir? Insert two polyethylene layers, one in the other, making sure not to trap significant amount of air between the layers. Binding technique: tie both ends with elastic rubber strips. Insert a 30 cm long T-shaped 521 mm PVC pipe in the double layer bag. The built-in pressure will ensure that gas flows automatically to the burner. The gas reservoir should be hung tidily, out of harm's way, and in a convenient place for use. They are normally hung below the stable roof, not too far from the kitchen area where the gas is used. An elastic band can be tied around the bags to create a stable output of gas during cooking. Loosen the band after usage to allow the reservoirs to inflate back to their original size. Installing the gas fan. Normally, using the above-mentioned device, the gas pressure should be sufficient pressure for cooking. However, if this is not the case, it is also possible to install a small gas fan pump to help suck out gas from the digester and push it towards the burner. Such a device is available with a small 6 to 12 volt adapter. It is advised to be installed nearby burner for convenient use. Turn on the appliance only when the gas is required. Installing the gas burners. VACVINA manufactures affordable and easy-to-use biogas burners. The burners are made of cast iron with copper regulation valve. Designed like the standard LPG burners, they are, however, much less costly. The burners are placed on the stove platform once the installation of the gas pipeline and all the fittings has been completed. The biogas burners are connected to the pipeline through a water valve, fitted under the platform. Before fitting the valve, apply lubricant on the surface of the bowl inside the valve to ensure smooth and easy operation. Important safety issue. To prevent children from opening the burners, a main valve must be installed at a suitable elevation and near the platform. Before using the burner, the main valve is opened first before the gas valve. The main valve as well as the burner valve are closed when not using gas. Side filling. After completing the construction and installation of the system, all remaining excavated areas must be carefully filled back. The best material to use is sand, especially around the digester outer walls. The sand layers should be sprinkled with water and tightly compacted. Operation and maintenance. Fitting the biodigester. First of all, it needs an initial cleaning and verification of the system. Before putting the biogas system into operation, the digester must be cleaned thoroughly to remove any spilled mortar or construction debris. In addition, all components of the system must be checked to ensure gas tightness. Initial fitting of the digester. The VACVINA biodigester was specially designed to recycle animal and human waste products, protecting environment and creating renewable energy for daily cooking. That's why the feeding materials are mainly animal dung and human excreta. In order to ensure the rapid production of gas for cooking, it is advisable to prepare 700 to 800 kilograms of fresh dung. The dung must be flushed into the digester with sufficient amount of water. The chamber must be filled with at least enough material to cover the bottom of the outlet pipe. Daily feeding of material. Fresh material must be fed daily in the digester to satisfy the cooking fuel needs of the family. To produce enough gas for a family of 6 persons, an average of 15 to 20 kilograms of pig or cattle dung must be fed daily. In addition, night soil will be added if a latrine is connected to the biogas system. Besides dung, water must be added daily in the ratio of 5 parts of water for each part of dung. The proportion of water is an important factor for optimum biogas production. Adding too much water will flush partly digested slurry out of the digestion chamber. Less gas will be produced and the slurry will not be sufficiently treated to remove old odor and parasites. In order to save feeding water, it's recommended to reuse water effluent from outlet tank. When large quantities of water are used to clean the pigsty or bathe the pigs during the hot summer days, this excess water must be drained and prevented to enter the biodigester. Production of biofertilizer at household scale. Nowadays, the use of biofertilizers combined with chemical one at a suitable rate is a potential trend for sustainable agricultural development over the world. This solution will bring a lot of benefits such as more efficient retention of NPK elements. This can be examined as the activities of the effective microorganisms present in biofertilizer will play an important role in decomposing hard chemical components and transferring them into digested elements and make nutrients ready available for plants. Decreasing environmental pollution from fertilizers by their proper use and limit maximally their unused parts. Improving soil fertility and humus contents due to increasing organic contents and activities of useful microorganisms. In other words, soil enrichment by higher levels of organic matter. To increase plant tolerance to external factors and to improve plant resistance to pests and diseases, consequently to reduce dose of pesticides and improving quality and quantity of crop production. Direct savings for farmers as they use less chemical fertilizers.